Alright, time for another draftphysics.com video presentation. I should check. Yeah, I should have checked it before I started the video. Sorry, computer's been a bit buggy. Anyway. This video will just be some draft things regarding magnetism and what was the other subject? The motion of the creation of atomic nucleuses and the energy that ends up being stored in the little bits, the electrons and protons inside of atoms. So, kind of narrow interest stuff. So first I'll just point again to this video on the mu mesons and the fact that I just really am requesting somebody who can figure out the catch, how they can possibly in this experiment distinguish between a entering meson and a decay event when they both produce the same photon, and how the experiment has any veracity in terms of them being able to claim they are measuring decay events when there's nothing in the technology that gives them the capacity to distinguish decay events from non-decay events. Anyway, it's explained in the video. But anyway, I want somebody, because this is sort of important. I mean, this is a well-established, this video has been on the internet, millions, I would argue, when you think about all the places the video has been over the years, have seen the video. It's incredible. It's just not credible. And nobody's pointed that out, that this is junk science. It's just doesn't have any veracity as a description of how they discovered a truth. There's no truth value in the video. And somebody should have to account for that. I mean, a physicist should explain either why such a piece of crap is still established physics, or explain how it's not a piece of crap. Okay, do one or the other, please. All right, I just can't get anybody to do that yet. All right, so on to the other stuff. So in thinking about the simulation and how it functions or will function, I should be able to show you something soon of that in action. The tricky part is getting this stuff to move around. I've explained all this. Proton and electron have different, they're interacting with force differently. So there's two kinds of force, and there's two kinds of, particles. And, proton, electron, there's proton force, electron force, when an X goes into an O, it's converted into an X, so an O goes in and X pops out, blah, blah, blah. And that's how you can create attraction and repulsion between these two objects. But the catch is how they combine. And the idea is the proton is heavier, okay? Now, physicists say it's 2,000 times heavier. I don't think that's right, because I don't think they know how to measure mass, because they're using mv squared, which is giving them fake answers. So they've exaggerated the speed of the electron and thereby exaggerated the portions of these mass ratios, because they've exaggerated it based on how much energy, kinetic energy, it takes to move them. Anyway, so this is an answer they've gotten wrong. So I would argue, okay, well, anyway, so the two things do eventually get smashed into each other, and frankly the pressure then just becomes even greater. The closer they are, like magnets, the stronger the force between them, and the less likely they're going to be broken apart. And so the question would be, yes, the proton is heavier, let's say 100 times heavier, some kind of number, but I don't think it's 1,000. The point would be is that if force hits the electron, it's going to end up turning into angular momentum. Okay, it's going to end up spinning around the proton, because the proton's the heavy thing. And the proton gets hit, it's going to move very little, where the electron would move, 100 times further for the same force impact. So you could say when these things are on their own, the electron is going to get hit from different directions, and it's going to gain momentum, but there's no reason why it would gain a lot of momentum in one direction. So the directionality would have to just be because of a subtle impact. For example, if a force was coming from this direction, what would happen is the electron, it was some sort of continuous force, something that lasted more than a microsecond or something. You could argue that the electron would go this way at first, and then it would encounter more force this way, and it would end up going back. So it would end up being retarded in its capacity to gain more and more speed in one direction. So the point would be is it's going to spin around the proton with a relatively meek velocity, because no matter where it goes, it's going to subtly get hit against its pressure and just as often get hit in the same direction as it's moving. So it's not likely to gain too much speed. Anyway, so eventually, let's say, because of that fact, there are times when the electron is not too busy, okay, not too active, not spinning too much, and so it ends up combining, okay, with another pair, okay, an electron and a proton, and now a proton and an electron, okay. And you could sort of understand that if I change that scenario, just to 2 electrons, all right, so let me get rid of this proton for now, all right, and so it just combines and gets an extra electron, and these 2 electrons then couldn't spin unless they both agreed on it, and that's not going to be very likely. So what they're basically going to do is oscillate in these directions where they'll meet each other's pressure and then oscillate back in the opposite directions. And so there's lots of room to have motion that, like this much motion, this much motion. So they're not going to spin around, that's for sure. They can't spin around the proton. So they're going to be doing a lot of this oscillating. And, that sort of agrees with what some of the physics, conventional science sort of says is part of the function, is some sort of resonant frequency that atoms end up acquiring based on these configurations. And so you could just see, if the more you complicate, you make this arrangement in a nucleus where you have more and more of these little electrons and protons associated with each other, you'll have all this little vibrational speed. In terms of something having to combine with it, would have to be able to tolerate the fact that the electron is in motion as they're connecting. And so it would account for a lot of rules about why certain chemicals don't combine with other chemicals and other chemicals combine easily with other chemicals. So anyway, it's just an interesting side bit that I found curious, that it sort of matches the idea of what they draw as orbitals, having these dimensions. Well, those dimensions are, the oscillating, the room it has to move in before it encounters the pressure from another electron. So the electron can only move so far before it starts feeling the pressure, the repulsion of the other electron, the other electrons that it's connected to, and they all end up vibrating, based on the fact that some of them have motion, and that motion has to constantly be adapted to. The whole system has to adapt to any motion. So one electron moves, and they all kind of have to move to adjust to these changing positions. And it's all time dependent in how long it takes that motion to get through a crystal of metal, for example, or some other factor. All right, the magnetism subject, I've talked about this a little bit before in the past, but the trick is that people keep thinking in terms of, that is, yeah, that's done. It should be done, frankly. This has lasted like 2 months. So, yeah, that's not going to work. All right, I have to get a new drawing device. All right, so we'll try to do this in 2 colors. So north, south, so it just doesn't matter which one you consider one color versus this other color. You can see the distinction between them. Yes, okay. So a magnet is sort of defined by this arrangement of electrons and protons. And I'm kind of arguing that surfaces aren't what we see. So we see through a little pupil. We're seeing stuff on an angle. And you could argue that magnets don't have eyeballs. They're not seeing things like we see them. Okay, they're seeing them in kind of just a surface. They're just a surface viewing a surface. And what's really happening is these rays are not going in all directions. They're going in kind of specific ones. What I do with the shit. Oh, it's always something. Somehow I lost this thing. All right. Hopefully these will all erase easily. Yes, thank you. So I'm sort of arguing that when something becomes magnetic, what's really happening is that the protons, let's say, are back here, and there's two configurations that this could be in. One where the electrons are in these kind of positions, okay, and one where the electron would be directly in front of the proton. So it's two different ways the electrons could be exposed, and in one condition it's north, in the other, and the red is coming out this way and this way, and obviously in the other condition, where this one isn't here, it's, red this way and then blue going that way. So it's what they're seeing, okay? And so you need to be magnetic to see magnetism, because you need to be exactly the opposite in terms of how you're viewing the other surface. You're seeing it as, when a magnet's looking at a magnet, it's really seeing it. Everything is just sending straight line force is the force that's the easiest to see, the stuff that's coming straight for you. And the stuff at angles is less likely to be as effective. And so, things aren't seeing things like with distance, it isn't getting smaller. All the stuff that's happening to us because we're looking through a pupil isn't happening to a surface that's looking at another surface. All right. So the obvious circumstance would be is this one's in this arrangement, okay, and the other side, okay, is doing exactly the opposite. All right. And then it would be attracted. So the other side, the other piece of material, would have its electrons and protons in exactly the opposite configuration. So I should be able to draw that reasonably well. Where the electron is in front. Okay. And so these two things could attract because the electrons would be in the right position for them to attract. They can match better than a circumstance where it's the other way around. Now I don't see, I didn't draw it right. Okay, so this should line up with this. Okay, so that's sorry. I mean, it's just poorly drawn. Mistake there. Okay. So you can see where the electron here can see the proton clearly. This electron can see the proton clearly, so that's why this one's drawn in the wrong location. And I haven't really drawn this out before, so that's probably why I'm doing it pretty sloppy, because I haven't drawn it actually. I've thought it, I haven't drawn it. So that's why you have the attraction, and obviously you have the repulsion where the electron lines up with the electron lines and the protons line up with each other, then there'd be repulsion. And that's really the alignment problem. Now the trick is obviously you could just slide this a little bit and then they'd be attractive. So the trick is that it's not, the pattern isn't just linear. As I've sort of stated, it's probably something more like a bullseye. So you can understand that the atoms are affected in kind of a ring kind of fashion, where one of them has an electron in the center and then the protons around it, so to speak. and the other one the other way around, so it's a bullseye, and you're really matching two opposite bullseyes. And that's the difference. That's why they can see the misconfiguration. So even though it's the same amount of blue and red coming out of both sides of the magnet, substantially the same amount, it's configured opposite. And so one side sees it completely upside down to its configuration, so it just sees the red or it just sees the blue because of the way it aligns. And so if it's aligned the same way, repulsion. If it's aligned the opposite way, the difference in the center, they attract. And so that's the pattern matching that takes place. So only a dipole, something that has these arrangements of more than one atom, can see another dipole. And only something that has the pattern is going to be able to interpret the pattern as being in alignment or out of alignment. If it's random, it's not going to see either configuration. Either configuration will just look like 50-50. It'll just look like purple, instead of blue and red. And it'll always look that way. But if it's the receiving end is receiving exactly the opposite of the emitting end, then obviously it's going to see that this is a place to be attracted. It's going to be pushed together. It's a push-averse. I could make that video over and over again. It should be part of elemental physics. So anyway, this is another whole subject that I can get into, but I'm just saying preliminary, it gives you a good idea of why magnets only affect things that become magnetic, dipolar, that create these bullseyes. If the atoms can't form into these consistent patterns, like in metals, in a crystal, then it can't see it. It's invisible. The pattern is invisible unless you have a pattern reader, so to speak. So yeah, that's probably enough on that subject. It's for the future. I'll have more to say. This is it's the same company. It's a different point. Strange. Anyway, at least it wrote. So what I have been going through a lot of the old 1950s and 60s and 40s videos. Some of them are so corny, but some of them would probably be good to play just as a point of, this is where it all goes wrong. They give you an example of gravity, and all they start talking about is pulling, how the ground is pulling you down, and pulling, and it's just such it establishes something as a fact when it's not a fact. That there's no evidence that demonstrates it's a pull rather than a push. Even if it was a bent geodesic, the bent geodesic doesn't say pull. There's no obligation for it to be pulling you down or pushing. There's no reason to think one way or the other about the idea of falling into a spiral. There's nothing that indicates it has to be a pull force. And it's just so once you think of it in terms of a push, then you can see it in terms of so many other things are doing the same inverse square law. Light and heat and lots of things create the same phenomenon. Anything that's basically being produced by something with spherical symmetry will produce the inverse square law. Any force that's admitted in any angular direction, even a spray can of paint, for example, and it's going to obey the same basic rule of spreading in two dimensions as it's admitted. And so sort of the point I'm making is the stuff between two magnets isn't spreading, at the same rate. And that's why it's kind of, I don't know if anyone's ever documented exactly how the force changes in magnets. They just say it's an R cubed in a vague way, but no one really tested it very well. And so it's it is kind of surprising that no one's taken, a microscope, and measured the force between two magnets all the way down, just to be sure what kind of relationship there is. So anyway, I think that's probably enough. It certainly does have an angular element. I mean, the whole point of me drawing these, the fact that it moves in a direction is part of the whole reason why it matters which way electricity is going. If it's going one way, it's showing an image at a 45-degree angle, and going the other way, it's showing an image at a 45-degree angle. And that's really what the magnet's seeing, is the angular difference. But again, that's another whole complicated subject, so we'll try to make a more coherent video on the subject in the future. Just stuff in my head. I just thought I would throw it on the floor and for your whatever bemusement and such. So yeah, I'm always working on something. There's no downtime here. Brain is always contemplating some bullshit. The whole right-hand rule thing is still, like I said, I got half of it. I got a piece of it, but I just don't have the whole story yet. So, and that's what that's the thing sitting in the background. I mean, this Mu Meson video was bugging me for years because I couldn't figure out what the hell was wrong with what they were saying. I knew there was something wrong, and I just couldn't pin it down. And it's just so simply wrong. It's so profoundly wrong. You just don't expect a science video to be that profoundly wrong. And it's just profoundly wrong. All right. So, till the next time and such.